Now what about this example? This again looks like you need to use implicit differentiation. Why? Look at this. There's a y here, and there's a y square here. So it doesn't look like your usual equation, right? The y's are stuck there. But what's different about this equation compared to the last one is, this time we have this 2xy. Now, what does that mean? 2xy means you got 2 times x times y. Okay? Minus 4y squared, nothing strange about that. And then 3x. This is the problem. This is where many students get it wrong. Okay? The reason is because x, well, obviously x is a function of x, it's just x, right? But y is also a function of x. You can't see it here. There's no function of x given here, but you just have to recognize this. Both of these are alphabets. Yes? X is the alphabet that we do the differentiation for. Y always represents something else. It's not a constant, it represents something else. So when we differentiate this, these 2xy becomes like this. Let me give you a clue. It becomes 2 times something, and I'm going to differentiate this. Left side, right side. Sound familiar? We need to use the product rule. So let me describe this again. When do you need to use the product rule in implicit differentiation? When your equation has both the important alphabets next to each other, multiplied to each other. So it's one function multiplied to another function. You need to use the product rule. Okay? So let's do the product rule for this question. Get rid of all this. Okay, product rule. What's the left side? The left side is 2x. Okay, in case you've forgotten, product rule is KL doctor plus download KR. So KL, keep my left side. This is my left side. Okay, don't touch. Differentiate the right side. What's my right side? Y. When I differentiate y, I get dy dx. Do you remember? Plus, differentiate the left side. When I differentiate 2x, I get 2. Keep the right side, it's just y. Okay, I don't touch my y. Now I move on. Minus 4, differentiate y square. I bring down the 2. I write y as if it was like x squared. X squared becomes 2x. Y squared becomes 2y. I must remember to write the dy dx behind. Okay, because I'm differentiating y. When I differentiate 3x, I get 3. Okay, critical parts here, this one, this one. What do we want to find? We want to find dy dx. Okay, we want to find that. Now I noticed that this one has a dy dx, this one has a dy dx, this one here doesn't. This one has no dy dx. So what I'm going to do is, I'm going to take this one, put it onto this side of the equation. Okay, so I'm just going to write the remaining 2x times dy dx. This one I shifted over, and I left with this, minus 8y dy dx equals to 3. This comes over here, becomes minus 2y. I see that there's a dy dx here, there's a dy dx here. I factorize it out. Dy dx, bracket. I took out the dy dx, I have 2x left. Take out the dy dx here, I got minus 8y left behind. Over here, 3 minus 2y. So what do I want? I want dy dx. And you can see that the steps are looking similar now. I'm going to take this one, toss it over here. Okay? Because this is multiplied together, I need to divide. So 3 minus 2y divided by 2x minus 8y. Look, there's a y in the answer here. There's a y in the answer here. And as I told you in the previous video, this is okay. So your answer is this. This is your answer. We are doing implicit differentiation using product rule. Please remember, the key thing that I want to tell you in this video is you must use product rule on this. Okay, you have to do this. Big star here. This is where most people make careless mistakes.